Hello, everyone, and welcome back to the College of Glycation, a series devoted to unraveling the science of how sugar impacts our bodies through glycation. Once again, my name is Paul Reynolds. I'm a biomedical scientist and professor of cell biology. And as your host for today's episode, we're exploring the differences between endogenous ages and exogenous ages, or specifically, what is the impact of glycation products we make in our bodies versus those that we ingest with our food. For those new to the series, let's touch on the basics first. Glycation is the non-enzymatic process where sugar molecules like glucose bind to proteins, lipids, or nucleic acids. And what they do is they'll slowly form advanced glycation end products or AGEs. These compounds accumulate, damaging tissues and contributing to aging and disease. Today, we'll zero in on the key distinction, endogenous versus exogenous glycation. We'll explore their origins, how they harm our bodies, and which source, those made within us or ingested from food, holds the greatest sway. Let's first lay the groundwork with a refresher on glycation. This chemical reaction echoes the Maillard-Browning response that you see in, for instance, a golden crusted bagel. But inside us, it happens without enzymatic control. When sugars attach to proteins, they create unstable intermediates that soon transform into AGEs over a few weeks' time. These end products stiffen collagen in our skin and bones, they harden arteries in our cardiovascular system, and they contribute to cataracts in our eyes, among other areas of the body. The damage builds up with inflammation and oxidative stress amplifying the harm across all of these and other tissues. Research that I'll reference a few times today was published by a group led by Dr. Uribari in 2010. The team published research that showed there was a long-linked glycation process to chronic diseases and chronic conditions like diabetes and cardiovascular disease. And this research, among others, urges us to pay attention to this silent process. With this foundation, we're ready to now unpack the dual pathways of endogenous and exogenous glycation that can shape our health. Endogenous glycation refers to AGEs produced within our bodies. It is a natural outcome of our metabolic machinery. Every time our cells process glucose for energy, excess glucose can bind to proteins, especially when blood sugar spikes. Say, for instance, after a carb-heavy meal or in unmanaged diabetes. This internal production is ceaseless. It occurs without interruption in our bloodstream, organs, and even in our brains. The effects are personal and profound. These AGEs cross-link proteins, reducing elasticity and leading to wrinkles, for instance, in the skin, brittle bone tissues, compromised blood vessels, and of course, stiffness and other issues related to aging. Our liver and kidneys try very hard to clear these AGEs, but as Vlasara and Pallas noted in their published work in 2002, this efficiency of clearing AGEs by livers and kidneys drops with our age or in cases of poor health, letting the damage excessively accumulate. In 2017, there was a study published by Aragno and colleagues that further suggested this internal glycation accelerates when we are experiencing added oxidative stress, making this oxidative stress a persistent internal challenge that we cannot fully escape. There was an episode a few months ago that focused on the details of oxidative stress. Feel free to check that out. Alternatively, In exogenous glycation, meanwhile, involves ages we take in through our diet. They're usually formed during the cooking routines that we employ. When we fry, roast, or grill foods, imagine the crispy edge of an overdone steak or the caramelized top of a sugar-heavy dessert. Proteins and fats can react with sugars and create preformed ages outside the body. That same 2010 study by Urabari and colleagues I mentioned moments ago found that foods like grilled meats, think excessively grilled meats, and processed snacks are rich in these compounds, which then enter our system when we eat them. While some of these exogenous ages are excreted, others are in fact absorbed, adding to the total burden of ages we experience. The impact depends on how much we consume, of course. A diet, for instance, that is heavy in extra charred or excessively sugary foods can significantly boost exogenous age levels. There was research published over 20 years ago in 2004 by a team led by Goldberg that indicated about 10% of the dietary ages that we ingest actually persist in the body, infiltrating tissues and worsening damage. Now, the gut can mitigate some of this load compared to the constant internal production. Further credence should now be given to our liver and kidneys again for doing a great job of clearing them. But again, although 10% are retained, the higher the intake, the bigger burden that small percentage can become. What sets these two kind of dual sources apart, endogenous versus exogenous, in terms of sources, is a story that's worth describing. Endogenous glycation is an unavoidable internal process driven by metabolism and blood sugar levels. It's a personal battle influenced by genetics and lifestyle, as highlighted in a study a few years ago published by Dr. Yang and others in 2019. Their focus was on diabetic complications. Exogenous glycation, however, is a controllable external input. If you choose more often steamed foods over excessively fried foods, you can lower the intake. The relative impact is debated, however. Endogenous ages likely dominate due to their non-stop production, especially in a high sugar state, and their deep integration into long-lived proteins like collagen. There was a study published about 20 years ago in 2004, and the researchers suggested that exogenous ages from fructose-rich diets add a notable but secondary burden, particularly in those with impaired clearance, like in the elderly, for instance. A few years before that, Vlasra and Pallas in 2002 published research that underscored that internal ages drive chronic disease progression, while dietary ages are likely those that act as an accelerant. Both have a deleterious role to play. Both lead to compromise, but there may be a bit of a pecking order. The tissue damage unites both sources in a shared story. Ages, whether homegrown in our bodies or imported through our diet, cross-link proteins efficiently, leaving skin less supple, arteries less flexible, and joints prone to arthritis. In the kidneys, we've already talked about in a previous episode, age accumulation impairs their ability to filter. And that point was reinforced just a year ago in 2024 in a study published by Dr. Wang and colleagues on kidney diseases. In our eyes, as I've suggested moments ago, age accumulation fosters cataracts, while the inflammation they trigger creates a vicious cycle. Endogenous ages may start this decay with their constant presence, but exogenous ages still have a role to play. As noted in 2018 in a study by Ree and Kim, this amplified the story, especially from those that frequently consume high-age foods like processed snacks. This interplay between endogenous and exogenous suggests a gradual decline we can only partially reverse, urging therefore a closer look at both internal, metabolically driven age formation and other dietary factors. So as we wrap up, let's reflect on this dual threat. Endogenous glycation is an internal hurdle that we manage with better control of blood sugar and exercise, while exogenous glycation offers a dietary lever that we can adjust every day. The greater impact likely comes from within due to its relentless nature, those internal, endogenously made ages. However, as I've mentioned repeatedly, external sources cannot and should not be overlooked, especially in today's processed food culture of convenience. The evidence from peer-reviewed studies backs all of this up. You're welcome to look at the show notes to review some of those references. If you're battling excess glycemia and want to protect tissues from excess aging, consider how your diet fuels the process. I'm not saying never eat a processed snack again or eat birthday cake on your birthday, but a diet that is more often than not low in carbohydrates avoids the peaks, and a diet that instead favors ketosis might ease the load. When we understand how glycation damages tissue, we can take steps to interrupt that process and rebuild. Thanks for listening, everyone, to the episode today that focused on endogenous and exogenous glycation. By eating smarter, the dual threat of internal and external glycation can be decreased. Thanks again for listening and joining today. I'll see you next time.